The theorem for existence and uniqueness. Consider the linear ODE, that guy, as we usually stepify, where the coefficients are all real and continuous functions, including the right-hand side. Ooh, looks to be an addition. Ah, yes, the leading function is never 0 for any x. Because why? That would mess with our whole order. Because if it was 0, then we would lose a derivative, and it would be awful. Those functions on a real number line a, b. So if a0 is any point on that interval, and there exist constants that are arbitrary, then there exists a unique solution if O of star such that those functions' derivatives are equal to the constants. This solution is defined over the entire interval AB. Here's an example of something like that. We have x squared y prime prime minus 6xy prime plus 12y is equal to 2x. Well, is it guaranteed to have a unique solution passing through certain constraints? Mainly, y0 is equal to 0 and y prime is equal to y prime of 0 is 0. And if it is, find the c1s and c2s. So the first thing we're going to do is we're going to check to see if all those coefficient functions are real valued functions. Turns out they are. So we know a solution exists. Nextly, this was that addition that we had to add on in order to find uniqueness. Now we're looking at the leading coefficient coefficient function, and we find that it's going to be equal to 0 when x is 0. So we don't have a unique solution. So are we going to be able to find that c1, that c2? I don't know. Let's go through and let's see why this is not unique. All right. So what are we doing? We're taking the proposed function, and we're going to take a couple of derivatives of that, evaluate the constraints, just as if we were going to finish him when we were doing our finding solutions to these guys. We'll see that a little later when we do annihilators and other such things. So yeah, we get this general solution, and now we're going to go through and we're going to try to find our C. But this is not unique. So we know solutions exist because they're real valued functions. But now let's evaluate our derivative with our original constraint. We're seeing that it's going to zero out. Haha. Oh, I see. Draw some glasses. Yes. Now, let's check the other one, because we're trying to find a C1 and C2. In normal circumstances, if it was unique, we'd be able to get a system, and then that system would solve for C1 and C2, and then we could get our solutions. But you know what? It's not going to happen here. Boo. Study. Ask questions.